Hello, Professor Caffo, teaching assistants, and dear friends. I'm Aditya. I'm a part-time MPH student at the Bloomberg School, and I've taken this course, Data Science for Public Health and Biomedical Engineering. So me, Vinayak, and Sejal have teamed up to make this capstone project on air pollution analysis in the US. And the reason is air pollution is such a big public health concern, particularly in the developing countries. And we're not really able to effectively analyze or visualize the data from the air quality monitors that we have all over the places. So I will go ahead and demonstrate this app that we have made to visualize, analyze, and predict data for a particular pollutant called the PM2.5, and we're using its levels in micrograms per meter cube. So let's get started. So let's begin with the thought process. Since pollution is a public health concern and we wanted to do something on the US data set, so we looked up the EPA's website and we realized that they have a wonderful air quality system API that gives all this huge gigabytes of data in the public domain. And we realized that there's a wonderful R package by the name of AQSR by Josh Keller, Roger Peng, and Daniel Bright, which allows us to harvest this data. And then we have a package GG Animate, which allows us to knit together all this beautiful data into a wonderfully easy to understand animation. Along with this, I used geocomputation with R to put it on a map. And this is where we started. So our app presents PM2.5 level trends over the last 25 years in US across all the sites, and you can see the trends, how the colors change over particular geographical locations as the years pass by. The visualizations tab allows us to visualize data of any one particular state. So for example, I'm showing Texas here. I could go to, let's say, California, and that will show the PM2.5 levels for any one year that I choose. Like I've chosen 2013 here at the different sites, and the graph will show the comparative PM2.5 trends of the state as compared to the other states, so that we can know which state is doing how much. This is like an overview. So the detailed analysis then lets us select a particular state and a county. So I've picked up California here, and so I picked up Kings and Lakes County, and so we can see the cyclical trend here. We can see the different cities here and the PM2.5 levels. And what we're really interested is in the monthly PM2.5 levels. So if we see Kings County has really high PM2.5 levels, and that's somewhere in the winter months of November, December, and January, whereas the Lake County is really less of PM2.5, and it peaks somewhere around July, August. And overall, we can see across the years, Kings County is a lot more polluted than Lake County. So this just allows us to compare across any two counties, across months, across years, and we could choose as many counties as we want. The offline app that I put in the GitHub repo has a feature that will allow us to do for every state. The one we have hosted on the web has only 3 states to keep the data set size small and the app to be fast. The prediction tab is, it's mainly the hard work of my teammates Sejal and Vinayak, and I'll let them do it. I have already done machine learning in my separate course at Hopkins through the course Statistical Learning, and I didn't want to repeat it. And lastly, the app is live on Shiny Apps. It does have a detailed README file at the repo. You can just go check the link below, and it also has a detailed instructions on what all you could do with it. Further, if you are willing to put in your email and the password that the AQS API gives you, you could harvest the data and customize it to use it to your own liking. I hope you liked our app. Thank you very much for listening to me, and have a good day.